in my hands I have a transformer. This is a 15-volt step down transformer that we're gonna use. Remember, during our part 1 in the theory, we said we're going to use a 12-volt transformer. It's very small in size because I'm gonna be using this box here where I'm gonna enclose my whole circuit, so you can see how it's fitting nicely. So because I have a 12-volt transformer and it's much bigger, it's a very big transformer. So I it's not gonna help me because I want to enclose my circuit in this black box. So if I have to put this 12-volt transformer in this box, you can see how even height, in terms of height, I would not be able to close my box. And if I have to put it like this, it won't even go in. So that's why I've replaced this because my 12 volt is much bigger. So I should have ordered a smaller one. So I have a 15 volts that is very small and it's gonna do the trick just fine. So it's a 2 watt uh, step down transformer. So obviously you can see this, the red wires are thicker than the blue wires. So this is gonna be my primary. So this is where the AC is gonna come in, and uh, this is gonna step down here using this blue wires. So that's the secondary winding. So this is my transformer, and it's fitting in the box nicely. So we're gonna talk about the box later. Um, on my AC, I also have a fuse. So this is my fuse and my fuse holder. So the fuse is obviously inside. Let's hope it is there. Yes, there's my fuse. So this is the fuse. So this fuse and fuse holder are big, but yeah, this is all I have in my stock. So yeah, this is the fuse holder. So you put the fuse inside and then you lock it. So that's it. So, and I also have, this is the switch that I'm gonna use. It's a single pole double throw switch. So I'm gonna use the middle, which is the common, with one of the pin, either the left or the right, to open or close the contact. So that's the switch I'm gonna use. Yeah, very simple switch. So that's my AC parts. These are the components that's gonna be part of my AC. Now, here I have uh, the rectification. So I'm gonna use this diode. I'm gonna use 4 of this diode. Remember the rectifier circuit, which was using the bridge rectifier, we were using 4 diodes. So this diode, it's a 1N4007. So that's the diodes that I'm gonna use. I'm gonna take 4 of them to build a bridge rectifier. And obviously you can tell that the pin on my left side, that's the anode, and the pin on the pin on my right side is the cathode, because the line, the silver line, that's that's the line that indicates the cathode of any diode. So all diodes are like that. They have a line, it can be a black, silver, or in this case it's a silver line. For rectification diode, usually you're going to see a silver line indicating the cathodes, which is the negative pin of the diode. Some people, instead of using the diode to build a bridge rectifier, they would prefer to use the bridge rectifier itself. It is practical. So you can see it's very simple. You can see with my bridge rectifier, oh, let me use a pen or a screwdriver. So you can easily notice that this is a plus. So yeah, that's a plus. So it's indicating the positive pin of the bridge rectifier, and that's a minus, which indicating the negative pin of the bridge rectifier. And the 2 pin have AC written. So this is where your transformer come in. So the 2 pin of your transformer come in this 2 pin in the middle, and on your left is your negative, and your the right side is your positive. So what does it mean? So you bring AC in the middle, the 2 pin in the middle, and you collect DC out. So on the pin on the left negative and the pin on the right positive. So some people would prefer to use a bridge rectifier integrated circuit like this. But for the purpose of our project, we want to see how you understand and how you build a bridge rectifier and understand the different connections yourself. So we're going to use the diodes to build the bridge rectifier. It's very simple. And after the bridge rectifier, we have the filter. So remember we said we're going to use the simplest filter there is, and this is the capacitor filter, which is very practical, very simple. So we said we're going to use a capacitor of 2000 microfarad, as you can see there, 2000 microfarad and 25 volts. That will do the job. So we discussed already the purpose of a rectifier. So that's the rectifier uh, capacitor that we're going to use. And after the rectification, we have the voltage regulator. So voltage regulator, that is our voltage regulator IC, which is the integrated circuit, and this is the capacitor that's coupled with the voltage rectifier, voltage regulator IC. So as you know about the voltage regulator, so as if let me see if I can get you to read that. Let me see. It's quite not easy, but I can read it for you. This is L7805. Remember, we said 78 indicates that this voltage regulator is going to produce a positive volt. And I have another one here, which is 7812. So 78 indicates that it's going to produce a positive volt. Here on the spin here, we're going to produce a positive volt. 0.5 means that positive volt is going to have the value of 5 volts. So this is your in pin. The in pin is here, and this is the ground that goes to 0 volt, and then this is the out. This is where all the voltages are going to be produced on the spin here. Same thing here. So it's 7812. 12 means 12 volts. So it's going to produce here on the spin plus 12 volts. That's the pin that's going to show the voltage. So the in is here, and then the ground is there. And the capacitor that we said we're going to use, in this case we're going to use a 0.1 microfarad capacitor just to couple with the voltage regulator circuit. So that's the voltage regulator. After that, we're also going to use the indicating on and off indicator circuits with an LED and a resistor. So we selected orange brown, which is a 330 ohm resistor, just to limit the current that's going to flow on this LED. So the long pin, as we know it, the longest pin is the anode on this LED. So long pin, I hope you can see that there. The long pin is the anode, the short pin. So anode is the positive pin, and the short pin is the cathode. So this is the longest one, and this is the shortest one. We'll even also have the green one, which this is the longest one. So this is the longest pin, this is the shortest pin. So anode, cathode, positive, negative. So that's how they do. And then when we produce our voltage and the output, so we're gonna want to use the female banana connectors just as your out to indicate your outputs. These are female ones, so we're gonna use them. We're gonna hook them on this box here, just to collect our voltage that we're gonna produce from the DC power supply here. So the black is going to indicate obviously the negative, and the red is going to indicate the positive. Alright, so what else? Okay, we're going to use this. These are the LED sockets. LED sockets. So we are going to drill on the box and then put them in there. And we are going to neatly, you're going to see they're going to display. You see how neat they're gonna look. So when we hook them, it's the socket for the LED. They hold. You can also call them LED holders. They hold the LED just to look so nice, to give it a nice look. Instead of drilling or burning the box, we can just use this LED socket or LED socket or LED holder, just to hold the LED on our box nicely. So that's it. What else do we need? So what else are we gonna use? uh, we did not talk about this, the plug. So this is the plug that's gonna bring the supply to the primary of our transformer. So we're gonna plug this to our electricity supply, and so we're gonna bring the AC voltage to the transformer using this plug. So that's how it's gonna work for the AC side also. And what else are we gonna use to build this, the which components for? And this is the Vero board. We call it Vero board or strip board. So Vero board is gonna be used. We're gonna have to cut this. We're gonna show you how we're cutting it also, and we're gonna build. The soldering is happening at the back here, as you can see, and the components are being put on the top side here. So front side you put component and you solder them at the back. So that's what we're gonna do. We're gonna use the Vero board or strip board. What else are we gonna use? So I also wanted to discuss a little bit about this box here. So we're gonna do all the drilling and the layout that's gonna happen. But for now, what you can know that this box here is uh, 120 millimeters long. So 120 millimeters long, or what you can say 12 millimeter. Okay, it's actually 12.5 if you just take it like that. So somewhere here. It's almost, let's say 13. It's 13 centimeter, which is 130 millimeter long, and so 130 millimeter by let's say 7, close to 7 there, 6.8. We're talking 6.8 centimeter or 68 millimeter. So that's what we're talking. And the thickness or the volume is 4 centimeter, which is 40 millimeter. So if we put it on millimeter, we're talking 40 millimeter there. So that's the box. It comes with this lid or the cover. So once I'm done, I'm gonna cover, label everything the way I'm supposed to label. So it's gonna come in handy. It's it's small, but it's kind of big also, because we nowadays we have chargers which are much smaller than this. But yeah, it's gonna come in handy based on the type of project we want to build. Okay, for soldering, I'm going to use the solder. This is the solder wire that I'm gonna use. It's a 0.9 square millimeter solder. I think this thickness is enough for me. I prefer this one. Some people prefer smaller than this, like 0.5 square millimeter. I prefer this one. It has 2% flax in. Everybody knows that the flax allows the better soldering. So flax, 2% of flax in. So that's my solder wire that I'm gonna use. I have the soldering iron, my soldering station that I have on me. So here's my soldering station. So there is my supply cable. There's my supply cable. So for my soldering station, a very basic soldering station. It's affordable. So there is my my soldering iron holder, because it's very important. You don't want to put it on the table. It may burn stuff. It may burn everything around. So this is comes in handy. It's a very basic station. I have here the sponge. The sponge must always be wet. It is wet now, because I asked my son to wet it for me. So it's wet, as you can see. So the purpose here is to always clean the tip of your soldering. It's not hot yet, because when it's hot, every time I clean it's gonna remove the dirt of your solder that's stays stuck on your soldering iron. So it keeps your solder tip clean, so that you can perform a clean soldering. What else? That's the switch where you're gonna turn on or off your solder station. So it's quite a very useful station. It's not very professional, but it does a professional job. So um, what else do I have? I have bunch of screwdrivers. You know, as a technician, always keep your screwdriver set with you. This is very basic. I'm not doing uh, a very hard job. It's not a heavy duty job, so this will do. This will do the trick. So this is my set of my screwdrivers. I have all types that I will need, but I'm not going to use a lot of screwdrivers. So I have the long nose pliers, the side cutter. I should procure myself the small one, but this is all I have with me, and the knife, cable knife, mostly to cut when needed. So I'm gonna do that, and I have the desoldering pump. The soldering pump. When you make a mistake while you're soldering, you use the desoldering pump to suck the solder that's overlapping or where the mistake was done when you want to desolder a component. So it's very important. The soldering pump. Okay, this is also one of the long nose or holder pliers that I'm gonna use. It also helps me just bend some components. I'm gonna need to use the wire stripper. That's my wire stripper that I'm gonna use. Yeah. So let me take this out. So these are some of the tools that I'm gonna use. Okay, I also have the helping hands. So when you're doing soldering, especially if you while you do soldering alone, so you can see that my solder station did not have this because some solder station they come with your helping hand together that mine didn't not. So I'm going to use this helping hand to help me. First, the purpose of this helping hand is to help you hold the boards that you're going to solder because you are working alone. There is no one to hold a board for you, so you can use this helping hand just to hold the solder for you. Now you can perform your soldering there. You're going to see how we're going to do it. But the other thing is that it comes with a magnifying glass. For those of you who have sight problems, you can always use this magnifying glass to check and see where to enlarge your component, because remember electronic components are very small, so you need sometimes to use the magnifying glass just to give yourself a better view of whatever you're doing. So the magnifying glass comes in handy also, but my sight is fine, so I usually don't use it. That's why you can see that I have put it like that, so I usually don't use the magnifying glass. All right, so that was the helping hand, and you are going to need to perform measurement also. So very simple multimeter, digital multimeter. When we start using it, we're going to tell you what this is. These are the probes. This is the selector, so you select the type of voltage or current that you want to measure, and there you go. So very handy. We're going to use it also. We're gonna do the variable board or the strip board layout planning. So we want to decide how these components are gonna fit on the soldering board. So first of all, we're not gonna include the transformer as part of our planning because the transformer is gonna sit on the box that we're gonna use. So which means our circuit is gonna start from this point here. So our circuit, we want to start our circuit from point L and from point N. So here's one small thing you have to know about the Vero board. You can see that it has holes. That's where you're gonna plug your components, and those holes are aligned horizontally. I have aligned my board horizontally because I have a better perspective, a better view, a better understanding when I'm putting my component when the board is horizontal, because I've met some people who put the board vertical and they align the components, because every time your board is horizontal, for example, when your board is horizontal, you're gonna have to align your component vertical because the connections are horizontal. I'm going to explain to you what that does mean. And some people I've met, they prefer to use a board that has connection line vertical, so that they can connect the component horizontal. So it's depends on your perspective, the way your brain operates, the way your brain view things. So mine better, and the people I work with, obviously. So we do an horizontal. So I put my boat on a horizontal position, which means my connection lines are horizontal, and then my components are going to be connected vertical. So for example, you can see that it has holes, which means my board creates horizontal connections like that. So what does that mean? It means if I take this terminal of a transformer, I plug it on one hole, that hole creates an horizontal connection for the transformer, which means anything that must be connected to this point here should be nothing but the component that has on the circuit. According to the circuit, you can see the only component that has a connection to L, this connection L, are D3, the cathode of D3 there, and the anode of D1. These are the only connection to L. Those are the only connection we have for L there. It's only D3, this diode here. D3 cathode is connected, the negative part of D3 is connected to L, and the anode, which is the positive part of D1, is also connected to L. That's the only point. So it means on this line here, if I had to connect a component on this line that I can call L, so the only components that must be connected, which should be the cathode of D3 and the anode of D1. I'll show you what I mean. So for example, if I create a connection here for my transformer wire L, that's the L line. So which means this whole line, now it's the L line connection. I can even label it here L. That's the L line connection. So what does it mean? It means that only the cathode, according to the circuit diagram, only the cathode of D3 and the anode of D1 should be touching that line. Nothing else should touch that line. I can also label it on this side L. So that line there, that's the L line. So let me show you an example. For example, I'm going to take the cathode of my D1, cathode of my D1. So I'm going to create a connection there. This is my diode. I'm going to go all the way down there because I want to. So the cathode is looking on the L side. So there. And then I create a connection there. So that is my D3. Sorry, D3. That was D3. That is D3. So I know why I've created a long connection like that. It's fine. It makes sense. So there's my D3 there. So this point of the anode of my D3 is there. It's gonna create a negative connection there. That's it. And the other point, so there, it's touching the L. So I made it a little. Let me redo that. Made it a little too far. Okay, so let me create a connection. So there. So I'll create a connection there on the line. This is the line of L. That's the only, and we said the only component that should be on L is D3 and D1. So we do that. So, and then I'm gonna draw my diodes. So that's my pin of my diodes. And then that's D3. That's D3 diodes. And I'm gonna come all the way somewhere. It's not a straight line. I want to create a straight line, so I'm gonna come all the way to here. Create a connection there. That's it. So here is my D3. So that's it. So D3, I stop it there because remember, at this point where the anode of D3 is, they're gonna come another anode of D2 there. So we're gonna do something also there. Now, if you have noticed, I'm not trying to recreate this diamond shape on my layout. I don't want that. It's not gonna look neat. I don't want to put my component like that. I don't want that. I want to put my component vertical. That's way I can easily have a better view. You can put it, you can recreate the diamond shape. It's up to you, the way you understand. I want to do something like this. This is the line. This point here, I turned it into a line. So now I'm going to connect my D3 there and my D1. D1 is not like that. D1 is going down. So I'm going, and then my D1 like that. So the cathode of D3 and the anode of D1, they are on the same line. They should be on the same line. So I want to create something like that also. But remember, at the same time, the cathode of D1 is the one that's creating the positive connection. So what I'm doing here is I'm gonna create another connection on the same line. Remember the live points. This is the live points where the D1 anode and D3 cathode are meeting. So I do that, and I draw my diode, which is pointing down there like that, and I bring it up to somewhere here. Let me put it here and create a connection there. So this is the point where I am here. Remember, that's the positive point. So it tells me already this line where I stopped my D1. This is D1. This line where my D1 is stopping, this line here, that's my positive P plus there. I'm gonna write plus there on this line here. That's where plus is. So this is the plus line. Anything that should be connected here is everything that must come on this line, the plus line. This is the plus line. There is also diodes, cathode of diode D4 that must also touch the positive. We're gonna get to that. So remember, I've already created the top part, this one. Now I want to create the downer part where the D2, is it D2? Yes, D2 is pointing down like that and creating another shape with D4. That's it, like that. So I want to recreate this, but I don't want to create this diamond shape. I want to create diode that look one that's pointing down vertically like this, creating a line here. That's your transformer. That's the other side of the transformer line, this point here, there. So that's the N of the transformer. If you follow the N here, you're gonna see that the N is joining there. That's this point here on this line. And now another one that's going up. So that's D4 going up there. So that's what I want to create. So remember, on my negative point, this was my negative point. This diode D3 cathode created the negative points there. Diode D3 created a negative. So on this line here, I'm going to follow the line, and then I have a negative points there. So there is a diode D2 that's going to the, so I'm going to recreate, I'm going to do this. So here there will be I can take that connection. Let me take it the same line. There will be a wire here. Let me use the black wire to show the negative, to show the neutral. It's fine. You can use the red. My transformer has red wires. So this will be the line where I'm gonna plug my neutral wire. It's also red, so it's fine. We can use that. So now here, which diode is taking me from the negative point? That's D2. You can see from the negative point to N is there. You can see that the connection of N is there. So that's what I want to reproduce. So I'm gonna plug this diode here, and it's pointing down to N. So I'm gonna create a connection there, and then bring my diode down, and then draw it. It's pointing down, which means the cathode is on N. And then from there, so now you see the line where N is coming, there is my D. Oh, that diode doesn't look good. Let me redraw this. I want some image that look neat. So some symbols that look there. There we go. We're doing good now. So like that. Let me redo that line. So that's my diode D2. And then The cathode is there, and I create a connection here on the neutral line. Also here I can label it neutral. So this line is the neutral line. Remember, anything that must touch that line should be a neutral line. I'm recording. Go plug it in charge. You can close the door. Joey, come close the door. Come close the door, please. Okay, so remember on that line where the neutral wire of the transformer is coming, this line here, the neutral of the secondary winding of the transformer is coming. So I'm going to label on that line, on that connection line, so end there and end there. So which means anything that should touch this line, you should check on the circuit what component is touching. It's only the cathode of D2 that's touching N, and the anode of D4. Those are the only components that should touch that line. That's it. No other components should touch that line. So this is my D2. D2. So now I've created my negative. Now I have to complete my positive connection with D1 here. So D4. D4 is going from the neutral. I can take that connection here. All the way to the all the way here. Oh, sorry. So this connection is coming here. So now you can see. So here, this line here represents my positive, and this one here represents my negative. So I'm here now. So you see, this is the point where I am. This here represents my positive, and down here to represent my negative. Let me remove this. So this here represents plus, and this here represents minus. So this is where I am. I've created that. This one here represents plus, and this one here represents minus. So what's next? What component is connected there? The next component that's connected between positive and negative, it's the capacitor. So it's easy to plug the capacitor. This is my D4. So with the capacitor, it's much easier. So I'm just going to get from this point the positive line. You can see this line here. And to the negative line, I create a connection there. So I'm going to put my capacitor. So that's C1. My C1 is there. So it's there, and it's a polarized capacitor, C1. So plus is on top, minus is there. So your positive pin of your capacitor, remember this is a polarized capacitor, should touch the positive, and the negative should touch there. Remember, no other component should touch any other line, right? So that's it. Okay, what next? So the next thing is the voltage regulator. You can see the input of the voltage regulator. You can see everything's here. Inputs, the in pin is touching the plus, and the second pin, the middle one, it should go to the negative. So how do I do this? How do I create this? So I can redraw my voltage regulator. See, these are my pin. I can put my first pin on the positive line, which means same line as this, positive. And so remember, the pin, your voltage regulator, the pin are close to each other, which means we're going to follow line per line. This is the third one. So, and then there. So that's my voltage regulator. So I have to draw it so nicely that I'm able to recognize my pin. So let me find a way to draw this nicely. Voltage regulator. There. So my first pin is there, middle pin, and third pin. So it's gonna be hard for me to redraw it, but this is my middle pin. My middle pin is there. So that's my voltage regulator. Let me just label it VR, voltage regulator, VR IC. So you can see my first pin, which is in there. My next pin is right there on top, pin 2, and this is my out. So I put it in this way because I have more room to create connection on top here than at the bottom, because I have my negative. So what I'm gonna do, I'm gonna take a jumper wire, because remember this pin in the middle here should go to the negative. I'm gonna take a jumper wire, plug it on the middle pin of my voltage regulator, and drop it down all the way to the negative. Now I've done that connection. It's good. Now the last thing is my output on the voltage regulator, my out pin. There's my out pin, so you can see that's my out pin. What is on the out pin? There is another capacitor there that's going straight also to the negative, so it's easy for me. That's capacitor 2, so I can just create a connection there on that out and create another connection there here to the middle, and then just draw my capacitor. So my capacitor comes there. That's my capacitor 2. C2 comes there, and then there. So C2. So there's a plus and there's a minus. Remember, it's also a polarized capacitor. So what else do? I follow my circuits, my last block, which is my on and off indicator block. There I have a resistor. Remember, resistor in series with an LED. When you have component like this, pay attention. Remember, this is a board. The holes are so small, you don't want to put two components on the same hole. Let me show you what's happening there. Let me show you what's happening there. So you don't want to put two components on the same hole. So what do I do here? Let me. So as I said, you don't want to put two components. Now you don't want to put two components. You can see you have. Okay, let me redraw it here. Now you don't want to put two components. You have a resistor and an LED in series. Now when you're doing the verboard layout, the connection is happening here, but on the verboard layout there should be a line. So when your resistor comes, drop on the line, the resistor creates a connection on that line. Now you don't want to put the two components on the same hole like in the circuit. You're gonna go to the next hole and plug your LED just like that, but there will be a connection there. So that's exactly what we're doing. So we're gonna come with the resistor. I'm gonna have to draw my resistor very small because I don't have enough space. Remember, I have only this point on the positive to this point on the negative. So I'm gonna start with my resistor somewhere there. But at the same time, you should also be checking that where you are creating a connection, there is nothing else already connected there. So you can see there is nothing. My resistor is supposed to touch the outputs. That makes sense. So but here where the resistor is stopping, there is nothing else connected there. You always have to check that there is nothing else connected there. That's why I preferred to go with my voltage regulator up, because if I went down, there was a lot of things connected. I was gonna lose that battle. So that's my resistor R. And this is the line where resistor R is created, the connection. So that line there is for resistor R. So I can just plug my LED on the next hole and then take it straight to the negative. So that's how it's going to be. My LED also is going to be very small. So sorry. So I'm going to put it like that, and then
like that, and then there. So I've created my connection for my LED there. So that's my LED, and that's my connection there. So now I have this. Okay, so the next thing you also have to include in your variable planning is the output, because remember we said we were going to use the female banana connector to create this output point. So we need two wires, so we're gonna have to include two wires. You can take it from here. You remember all this line is your output line. This is now the output connection. That's where we take all our connection. That's output, and the negative remains the same. Our positive is not our output. Our positive point was only the point created by the bridge rectifier there. But our real output, where we're going to collect the voltage that we want, is going to be this point here where the voltage regulator created the output. So where we can just plug two wires there. So I can put those wires. I can just plug two wires. Any point I decide to put it here. So that's my output plus 5 volts, and here will be my output 0 volts there. So I've created these 2 points there. So I'm gonna use these two wires to actually connect to the the female banana connectors, just to create an output point. So this is what we have to do. So when we are building our circuit, we want to reproduce this on the real board where we're going to do the soldering.
All right, so I have to cut. So we're preparing ourselves for soldering. So I have to cut this variable board is too big. This strip board, that's how we also call it, is too big for me. So I have to cut. I must make sure all my measurements, because I'm gonna fit everything here. So my transformer is gonna sit like this. I don't want it to go fully against the 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 wall here. So I want it to be somewhere here. So that's where I'm gonna put my transformer, and I'm planning my. You see, you can see how big is my fuse. So I want it to be this side here, like this, but at the same time also my switch should come this side. So that's how it's gonna be, which means I'm gonna save space here. This, you can organize this as you want. So my outputs points are gonna be here, like this, and my LED also is gonna come that side. So which means I have a space about how many so I can take a 6. So my board can be 6 centimeter long. Six will be fine. So it can start the 6 up to here, 6 centimeter long. And so I know this is the full board actually on the other side. So it's this side it's 10 centimeters. So I can take half of it. So I can do 5 by 6. I can do a 5 by 6. Let me use a screwdriver for that. A 5 by 6. So let me use a flat. You can also use a flat to cut this board. These boards are just like biscuits, just like cookie. They break so easily. You can use also a screwdriver, a flat, to cut it. So I'm 5. I'm here. But I have a knife. I'm gonna attempt to use a knife first, and then so 5 by 6. So that's my 5 there, and then 6. I'm gonna be here for my 6. So somewhere here. So yeah, there's my 6. So 5 by 6 is fine. 5 by 6. So I can just do that, and then when I cut, then So this is the whole piece that I'm gonna use for my soldering. So you can do that with a flat, and then here also like this. But I'm gonna use a knife because I got a knife. Those of you who don't have a curved knife, you can also use a flat screwdriver to do that. So you can just mark it until it's really easy to cut. So at that point, so once it's ready, you feel like okay, this is good to be cut. Then you can just cut. Okay, I see it's equal. Okay, now I can cut the 5. So and you can just break it. And you can just break it there. Alright, so which one should I take? Okay, I'm gonna take this one. I prefer that one. Okay. So as you can see at the back, so our lines are horizontal like that. So whatever soldering we do, so once we plug a component, we have to consider the horizontal connection. This is very important. All right. So here's how I'm gonna use my board. Uh, so if I turn like this, so here are my connection horizontal. So I'm gonna keep it horizontal. I'm not gonna put them like this, as I explained. So they're gonna be like this. So if I turn them back like this, so a component. I drew the circuit. So the planning, the layout, so I can show you exactly what these diodes. Let me cut the diodes. 1, 2, 3, 4. That's what I need. 4 diodes. Good. So as we said, this stripes here, this it's a silver line is indicating the cathode. So for example with D3, that's pointing up like that. So my D3 is gonna be like that. So that line is gonna be there. So this one is gonna go down this way. So this line is gonna be like, so it should form that half wave, and this one is gonna go down this way. So the stripes should always point down on D2, and D4 is gonna be like that. So on my board, when I'm inserting them, when I start with D3, so for example, so my D3, so I have to know that, okay, so because if I turn my board like this diode is going to be at the bottom here, but when I turn it like that, because I want to copy what is here, so it's going to be on top there. So do you guys understand this? If I put here, when I connect this diodes right here, let me not use the first, let me use it here, right here. So if I put it there, this is the line where my transformer is going to come, on this line here. This is where my transformer is going to come. That's where the two diodes are meeting. This is the line where my transformer is going to come. So I'm going to put it in like that. So I want it to be all the way down here because I want to create a negative connection. So and then it's going to go down. Let me bend my, so it can go down up to here somewhere, up to here. Okay, there it's fine. I can take it there. So this is that. Some people prefer to put all components first. They see if the wiring is fine and the connections are fine, and then they start soldering. I don't do that. So as soon as I put my first component, I solder it immediately. So that's exactly what I'm going to be doing. So my diodes, that's the first diode, this one right here, it's there. So you can see that it's there, and if I turn, it's actually on the bottom side. So that's how it is. So I'm going to try to solder this. I'm going to be bringing this layout every time, just to as a reminder. So this is what I'm going to do. I'm gonna use my helping hand to help me hold this board, and I really want my component to sit flat on the board. I don't want them hanging in the air. I don't want them hanging in the air. So that's what I'm doing. And one other thing, when you're soldering, avoid the solder to jump tracks. So here's my solder wire. I don't need that much, so I'm gonna just cut a little bit, not too long. Okay, that's all I need. All right. So I hope it should be visible. Okay. Good. There we go. It's clean. It's as clean as a new baby. So, and I'm just trying to make sure that it's gonna sit on the board nicely. So that's what I want to do, because this one already didn't sit. Okay, so now it's fine. And put it back again. Yes. So that's my diode 3. I'm gonna proceed with the other diode. So this one is gonna go from here. Okay, let me take it here to somewhere, because I want to create this connection here. This diode 3 is forming here the negative connection. I want to jump like 1, 2, 3 somewhere here and create my positive connection there. That's it there. So that it will be great there. So that's my second diode. So my transformer connection is gonna come here, and it connects these two diodes. And then here is my positive point that I've created there, and there is my negative point that I'm gonna create there. So that's it. And yeah, I'm doing my best to not uh, put a lot of component together, but usually you'll be advised to miniature, to keep your circuit as miniature as possible. I'm doing this, trying to keep some space, so you should be able to see, especially if this is your first time to do this. So at least you should be able to see how all the connections are made. So I'm gonna do the soldering again. As I said, I like to solder as I go. Put one component, solder. Put some people, they want to put all components on the board and start soldering one by one. I prefer to do this. This is very efficient for me. And you have to be sure, because if you make a mistake, you're gonna have to redo everything, or you're gonna have to desolder. So I don't want you to get to that point. So if you are not sure with your connection, please put all your components on the board, and once you are sure, then you can solder them. All right, so this is that. I'm gonna cut the pins later. Let me just finish everything. So this is how it looks here, and at the back here, the soldering looks neat. I don't know if you can see that, but it looks good. All right, So what are we putting now? So let's create a negative connection. So our negative connection comes there. So this diode is supposed to go like this. So it should point down. So as we said, if you can check on our drawing here, you're gonna see this diode D2 is pointing down. So my line here should go point down there. So we're doing good. And I'm gonna bring it here. So there. So it's fine like this. Alright, this is good. Alright, so I'm trying to hold it in a way that it does not fall. Okay, so we're good. Let's solder that. And if you are observing my soldering techniques, you're gonna see, because I've seen some people the way they solder. They bring the solder and iron once at the same time. Watch how I'm doing. I put the solder first, but not longer than 2 seconds. So once the solder is in contact with the pin, and then I join the once the soldering iron is in contact with the pin, I join the solder, then I remove the solder, I remove I remove the soldering iron, and I remove the solder. So this is good. This is looking good. So we're good there. And then we're gonna put the other diode. So this one was doing this, so you can see those lines. So they formed the first uh the first half, the first positive half. This one they're gonna form a negative half, so they should this line should go and this one should go up there, but it should now touch the so I can put it there. I can put it there. So it should touch D1. D4 touches D1. D4 touches D1. I could have also put it this side. I could have connected also this side. Uh, okay, to make it give a nice look so that everybody can understand, because this is a video I want everybody to be able to see what I'm doing. So there. So first of all, I put it here to there. Now I've decided to move it. Remember, these are horizontal line. The connection is there. So my first transformer is gonna come here, and the first pin of the transformer, the live is gonna be there, and the neutral is gonna be the on of the transformer to create. That's the AC connection, and my positive is there, and my negative is there. So this line here is my positive. This line here is my negative. So that's how it is. So let me solder. I really hope everyone is able to see what I'm doing. Okay. Okay, so I'm gonna solder here, pin here. Okay, let me check that it didn't fall. As I said, first let me clean the tip. Remember, I told you to always keep a wet sponge to clean the tip. You can see it's different now. So this is what I'm doing. First, you touch the tip of your solder on the pin for not more than 2 seconds. So I touch it there. Then I join the solder. Once the solder melts, I remove the solder. I remove the tip. Same thing. Touch the tip, join the solder. Once it melts, remove the solder, remove the tip. That's it. So that's what I'm doing. All right. So now it's looking good. It's looking good. It's not the best, but it's looking good. It is presentable. Anybody can understand what we've done. You can see our bridge rectifier there and there. My positive and my negative line are there. So I have now to consider this. This is the positive from the bridge rectifier, and the negative. So we have created this. If you are able to see, this is the positive that's been created there, and that's the negative there. Now your AC, your live and neutral, come there and there. So that's what we have done. Now, our next component is going to be the capacitor. From here, I can already cut my pin. Use my side cutter. I didn't find my smaller side cutter, so I'm gonna try to do it with this one. So I'm sure of what I've done, because before you decide that okay, I'm gonna trim my pin, so please make sure you are very sure of what you've done, because sometimes you're gonna need to desolder and connect that component elsewhere. But in my case, I'm positively sure of what I've done. So now it's looking well trimmed. There it is. So now it's gonna be the filtering capacitor. Remember, let me put this here. So the shortest pin is my negative. It also says the N, the negative sign. It also shows the negative sign. And here they don't show the sign, but this is the positive. So the longest pin is the positive. So they've already shown you the negative pin, and there's my positive. So remember, you follow. This is my board is like this. So so I'm like this. So this is my positive. Positives there, so the longest pin is going to be there. I'm going to try to create a space also. So and then, so if you followed me, you're going to see that this pin here is in line with this 2, and this one here is in line with 2. You can also go to the back. I want it to sit exactly on the board like that. You can also go to the back and verify that. You see that this pin is in line with it. You can check the tracks. Make sure your tracks are also clean. There. So this line is in line with this, and this one is on the same line as this. So that's it. So positively sure. So I'm gonna do the soldering. So far we've been doing good with soldering. So I'm going to all right. So there was our filtering capacitor. Now, after filtering capacitor, what do? Uh, I'm gonna connect the voltage regulator. Okay, so I'm gonna connect the voltage regulator. So which one do I have here? So remember on my video that I showed, we said we're going to connect a 5. So I'm gonna use the 12 that I have here, because I don't seem to find the 5 that I was having. But this is still the same thing. It's up to you. So which means what? When I connect the 12 volt, I'm gonna be reading 12 volt on my output. If I connect the 5 volt, I'm gonna be reading 5 volt on the output. Okay, there it is. There's my 5 volt. So the 5 volt is gonna generate 5 volt in the output. The 12 volt is gonna generate 12 volt in the output. So that's it. So let me connect the 12 volt. So if you want to generate a 5 volt, then you're gonna have to use a 5 volt. So I'll let me generate the 12 volt. So which means I'm gonna connect the 12 volt. Now remember, my positive pin from the rectifier is here, so it's coming here. So which means on the voltage regulator, this is my in, this is the ground to 0 volt, and this is the out. So I want to put it like this because I have a lot of room on the top side here. So I want to connect my in here like this. So I want my voltage regulator to face my right hand side. So my in is going to be there, and then my ground, and then my out is going to be on top there. So that's what I want to do. So I'm going to follow exactly this line here and somewhere here. So I'm going to put it there. So we're good. So just make sure every time you put a component, go and check that it's really on the pin where you wanted it, and it's exactly where we wanted it. This is the pin of the positive, and there is our in, and the ground is there, and the out is there. So this is when I turn like this, there it is. So when I turn it like this, it's here, and when I turn like this, there is my out. So that's where we're going to continue with our circuit. But let me turn it back and solder all pins again. So it's sitting well, and we're going to do the soldering. That looks good. Clean the tip again. So as I said, remember my technique. And this you are soldering on an IC. Integrated circuits are very sensitive. So what am I doing? I touch the pin for less than, not more than 2 seconds. 1 second. So once I touch, I join the solder, and I remove the solder. I remove the tip. That's it. I touch the pin with the tip, join the solder, remove the solder, remove the tip. That's it. So that's it. Not bad. Looks good. It it's looking good. So let me do the cutting again, just to keep a clean job as I'm progressing. Okay, this is good. This is quite, and the pin are not touching here. The pin are not touching. I'm just verifying that. We're gonna do a continuity test with the multimeter, but every time you can also clean just to make sure. But we're gonna run a continuity test with the multimeter just to confirm that no solder has jumped to the other track, because that's what we're trying to avoid. We don't want. You can see how these pins are one after the other. The tracks are just close to each other. So if some solder jump on this track, you will create a short circuit. So we are trying to avoid that. And in my case here, I can see it's really, we did really respect that. We avoided the solder to jump, this solder to jump here, or this solder to jump there. So it's looking all neat. So we've done quite a good job. So after, so we were here right now. So we just connected this 1, 2, 3. That's what we did. So we connected the in there to the positive, and to the positive also of the capacitor, and then this one and the next track, and we went up. So our out now is here. So if you check, our out is now here. So what are we doing next? We want to put this capacitor between. Okay, so you're gonna see on the planning that we're doing, our capacitor was coming from here all the way to negative. That's exactly the same thing, because we have a connection here in the middle. Before we put the capacitor, we have a connection here, the middle pin of the 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 middle pin of the integrated the voltage regulator is already bringing us the ground there to the negative there. So it's already brought us the ground. So we found it unnecessary to also just make a long jump today. So we can just, this capacitor can just go between out and the ground, because there is already a jumper that's bringing the negative there. So that's what we've done. So you can see there's no really motivation, more modification. So because this is the same as putting it down like that, so it's just the same. We're just avoiding a lot of jumpers. So here's what I've done. These are the jumpers. I just stripped them from a normal wire, a normal stranded wire, something like this. This is where I stripped it from here, from this one. Just stripped, take one of them to do the jumping. So I'm gonna put it in the ground, from the ground all the way. So I can put it right there because yeah, from the ground all the way to the negative. The negative is there. So from the ground to the negative, and make sure it lies flat on the board. So that's it. So that's what I've done. And you can see my negative line is there. And if you follow it, so but as I advise, always go back and check that it's on the same line. You can see all of them are on the same line. So we've succeeded, and also there on the middle pin of the voltage regulator there. So that's where we are. So and then we're gonna do the soldering. Always the same technique again. There we go. Nice and easy. So attach the soldering iron on the pin, and then I join the solder, melt, and I leave it there. Nice and easy. So my next thing, let me just cut it immediately. My next component is going to be the capacitor, the smallest capacitor. As I said, this capacitor is supposed to go between out and the negative. So I can just put it there. Out and negative. Remember, the middle pin of my voltage regulator is the negative. So I can just put it like that, and then like that. So let me do it like this. So I'm trying to avoid for it. Okay, so it's fine like this. Okay, so I'm gonna solder it. All right, there we go. Okay, my next component. So we're not going to be able to see the pin of the small capacitor and even the big one because I really made it sit on the board. So that's why it's solid enough. So my next thing is the LED. Remember, I want my LED to come on the box like this. So I don't want it to sit on the board because I want when I close my box, I want the LED to show here. So which means I must connect wires from the LED all the way to the board. But before that, we are using a 330 ohm resistor to limit the current that must go to the LED. So then we're going to do the LED. Let's first put the resistor, then we're going to go to the LED. So we won't have a lot of space. We have to just be careful as we're doing this. So here's the line where this is the out where I'm supposed to connect the resistor. So I'm gonna put it there, and every time make sure your resistor is connected, is touching nothing. So from here I can just put it to here and just make sure. Okay, it's nice there. Okay, it's right there. You can see here that my resistor is touching the out of the voltage regulator, but there's nothing connected to it here. That will be the joining point between the resistor and the LED. So they're gonna join, they're gonna meet there. So it's very important you always consider that every time you're trying to plug your resistor. So let's solder this. All right. And then let's solder this one. Okay, there was a little bit of solder flying there, but we managed to get it right. So it's right there. All right. Just trying to check my tracks again. There's no solders jumps. It's all clean. But we're still gonna do continuity test to make sure no solder is jumped the other side. Good. Now we're gonna take the LED and put the wires on the LED and then plug those wires here to continue the circuit. So we are just here. This is where we are. So we did this resistor here. Now this where the LED must come, we're gonna join two wires there. That's gonna the LED is gonna hanging on two wires. All right. So let's do our LED. Let's do the LED. So should be easier. So I'm gonna use the red one. So I'm going to. I'm trying to find a way, a technique to actually do this. I can do it like this. Just twist it a little bit around there. And then I can hold it like this. Okay. And then solder. So there's my solder. Okay, because we are soldering in the A, it's gonna be a little bit challenging, but yeah, it's working. Okay, there we go. All right, clean job. So let's twist. Let's put the wire on the second one. I'm gonna have to insulate this part because I don't want them to end up touching by mistake. So I'm gonna end up insulating them. But let's. So that was the anodes that I just soldered. So I'm gonna join the cathodes, the negative wire. So I'm just gonna make sure I do very, very clean soldering. So I want to make a nice twist. Okay, I'm gonna cut the rest, but this will do the trick. So I'm gonna cut the rest if it doesn't hold. So you always have to make a plan. You always have to make a plan because your creativity, your own design is also expected when you are doing this type of job. So you always come up with a plan. So I'm gonna do it again. This is looking good. Okay. Okay, not bad. So we managed to actually keep everything there. Alright, so I should wait for it to cool off a little bit. So this is actually good. So we've done a great job. And then these are pieces of my solder, my insulators. Okay, this should do it. So I want to cover this whole part, so I'll do there. So I'm using red to indicate that that is my anode. So because whoever is gonna have to troubleshoot the circuit should know that that is the anode. So I'm gonna insert it there and then just slide it there like that. And then okay, so uh I was having a heat blower which I did not I did not plug, so I didn't have enough space to plug the soldering iron, the camera, everything. So I'm gonna have to use my lighter, uh, which is also one of the best way. I'm not a smoker. I don't smoke. I just had to grab this lighter. So and you don't need to get it too close because just that little heat is gonna do the trick on this insulator. And there we go. Nice job. Job well done. So let me also melt that other parts. So as the heat, this insulator shrinks as the heat gets close. So that's what's happening there. So let me put the black one for the negative. Um, cut it there. So I think this will do it. Okay, up to there. And then all right. So as the heat reaches the insulator, it shrinks and sticks to the wire, and it creates a nice clean finish. So now it's easy for me even when I'm connecting this to know that okay, red indicates where my anode is and then black indicates where my cathode is. It's gonna be much easier because that's exactly what I'm gonna do. So I'm gonna have to twist this stranded, twist them, and then yeah. So my red is supposed to be on the same line as the resistor there. So let me put it like this. So there, I'm supposed to there, insert it there. So same line, I can insert it anywhere here, but yeah, let me just stay closer where my resistor is there. Let me just stay closer and put there. So that is my anode. My anode is gonna touch there. And my cathode is actually gonna come here on the negative. So my cathode is gonna come here on the negative, like that. So this is how it is supposed to be. Just hope they won't fall. So let me find a way to actually hold also the wire end there. That's good. All right. So I'm gonna solder. I'm just trying to make sure the stranded piece don't touch or don't create a bridge on the other track because that's what we're trying to avoid. If it creates a bridge, it might create another connection and a short circuit. So we're trying to avoid that. Good. All right. So clean the tip of my soldering iron. Take my solder and there. And do the same thing here. Now that's great. Now this is good. So I can now cut those ones. And here also. Just trim them nicely. Do a nice trim job. So now what do I have left? I've put the LED, I've put all components that must come, but I need my output wire. The wire that's gonna come and connect to this this connectors, this female banana connectors, because I need my output to be connected here. So I need, this is, remember this was my output, this pin here was my output pin, that's where I'm gonna get my output. So I'm gonna take another wire hanging there and another one from the negative also hanging there, so that the positive one comes to this and then the negative one comes to this. Remember, we did not use a 5 volt anymore. I used the 12 volts. This, it's not a problem. The same principle work. Even if you're gonna use a 5, you just replace the voltage regulator, the 5 volt voltage regulator. So I used my 12 because I think I'm gonna need this power supply. I want to supply a system that require a small system that require 12 volts. So that's why I've decided, why not just use this project to supply my system. So you can also replace it if you have a system that require 5 volts. You can also replace it with a 5 volt voltage regulator IC, integrated circuit. So that's what I did. Okay, so okay, you can see that I was, this is what I was afraid of. My wire didn't go in as I expected. As you can see, there's a little bit of wire showing there, but it won't touch. It won't touch. It's the won't touch it. But you should always make sure the wire just goes in nicely. It did not. We failed there, but it's acceptable. I will give myself 7 out of 10 just for this. So this whole layout, I will also give myself 8 out of 10, because remember, there is no perfect layout and perfect. Any person can come with a different layout. So I, if this project I was not for student, I was even able to use. I could have been able even to use a small piece like this. This piece I used was six by 5 centimeter. I could have been able to use even a 2 by 3 centimeter for this whole project. So that's there is no like best layout ever. So we just do our best in electronic to come up with uh, the smallest, the most miniature as possible, so of your layout. So this is good because I wanted something like this so that the learners, the student, can be able to identify and see each component, and at least be able to see each pin where it's going, as you can see, and how they are touching. So I wanted something a little bit open like this. So let me find my output wires and connect them. All right, so this, I'm gonna use this. I don't have small wires because I needed to have at least 0.5 square millimeter red and black, which I don't have in my possession. So this is also adapter wires. So I've collected them from an old DC power supply, an old adapter. So I'm just gonna cut it. So I need some piece just as up to there. I think this will do it. Okay, this is long enough. So up to there we'll do it. Okay. So let me divide them. So I can just, I think we can divide them. We can leave them like this, and then here, but we still have to divide them anyway. So this is the negative one. You see, you can see it. It's indicated the negative, negative, negative. So that's the negative, and this is gonna be our positive right there. So remove the insulation. We twist, and then remove the insulation again here, and we twist. All right. So this is the negative. It's gonna come same line, because remember, then you have a screwdriver. So our negative connection was here, and if we turn at the back here, this is the negative connection. All of these components are taking the negative or the 0 volt connection, all of them. So we're following the same line also, and we're gonna plug our negative wire there. So I can plug it right there. There. It's so let me put them one by one, because seeing my experience with the others, it did not hold well. So I'm gonna put the first one, solder, and then go to the next one. Okay, that is my soldering iron holder, which is just folding. Okay, here's my solder. So I'm gonna come here, solder the negative wire. Now smelting, and there we go. So go for the positive now. Go for the positive wire. So the positive wire, this is the out. The positive is on the out. Remember, the negative, if I bring the layout diagram again, remember our negative output, which is the 0 volt, is coming straight from the bridge rectifier. That's there. So you can see the two diodes are connected there. The capacitor negative is also connected there. The negative wire, the ground wire from the voltage regulator, is also connected there. The LED negative pin, which is the cathode, is also connected there. Then we connect our negatives. That's what we did there. But the positive is not coming from the bridge rectifier. No, the bridge rectifier positive is only stopping at the input pin of the voltage regulator. Then the voltage regulator takes that voltage and regulates it to 12 volt. We've used 12 volt here. You can use a 5 volt, you can use 9 volts, whatever voltage. But yeah, so I've used a 12 volt here. So we reach here from the voltage regulator, it stops at the inputs of the voltage regulator. I mean, from the bridge rectifier positive side, it goes to the input of the voltage regulator, and then for the output wire, we're gonna take it from the output pin of the voltage regulator there, and this is where we are. It's right here. So we're gonna take this wire here, and we're gonna plug it there. So that's where this wire is going there. So I can remove my diagram. So that's why it's going there, and then we're gonna do the same thing again. We're gonna ask our helping hands to help us hold this nicely, and there we go. So I'm just trying to make sure it's there. So take my soldering iron, clean it nicely, and melt my solder there. And there we go. Nice melting, clean. So that's it. So now my two wires are there. My two output wires are there. So this is the positive, and this is the negative. So I can trim them nicely. Always keep a side cutter to trim your pin. Now it gives a nice finish. There we go. So what do we have left here? We have to bring the transformer, but you remember there is a few connections that must happen on the transformer, because I'm going to use this, because our transformer, on the primary side of our transformer, so what we've done so far was only the secondary side here, because these wires, this one here, the live of a transformer, the neutral, the AC part, so it's coming in here. So we know that the one wire of the transformer AC is coming in there on that line, and the other one is coming there on that line, anywhere on the line, but we're gonna keep it that side. So this we've done. So this wire is just gonna come here. Now on this side here, here we have a fuse. So our fuse is there. That's the fuse. So the fuse is on the live side, and after the fuse we have the switch. And from the switch now we go to straight to our plug. So you see on the live side, this is the live side. There are two components that's going to be connected there, our switch and our fuse. And so we go from the live wire of the transformer to the fuse. One pin of the fuse and the other pin of the fuse goes to one pin of the switch, and the other pin of the switch goes to the plug, and the other one of the plug goes straight to the neutral pin. So that's what we're gonna do. We're gonna reproduce that because this is all gonna happen in the box. So, but this is exactly what we're gonna do. All right. So after we have soldered, I think I want to make sure my circuits. I know it's soldering is perfect, so I just want to make sure. Um, so what I would do here, I would just use the knife in between the space between the tracks, just to make sure there was no solder overlapping. Yes, you just want to make sure there's no solder creating a bridge. I have some flax, but it's not really solder. You know, flax is there just to give solder a nice finish, and yeah, to keep things smooth. So I usually have to do this. So usually I would do this after I'm done my soldering. I would just use my knife or my thin flat screwdriver just to browse in the space between the tracks and make sure no solder is bridging where it's not supposed to be. So everything looks good. Everything looks good. So I'm gonna perform continuity test just to confirm that. So I'm just gonna confirm that with the continuity test. So let me try that. Okay, mostly it's okay. I'm gonna have my multimeter there. Turn on continuity. So my continuity is right there. So if you can see, there's the symbol for continuity. So I have just to select it. So I'm on milliohms, and then I go continuity symbol is right there. So, and to make sure your multimeter is set on continuity, let's touch the two lead. It's gonna make a sound. The buzzer will give a sound. So I'm checking between the tracks. Okay. Okay, there's nothing now. There's nothing between the two tracks, so we're good. And here, there is nothing, so we're good. So the solder looks good, and everything is fine. I see something here. Let me check there. Also nothing. So there is no continuity. My board is good, and the soldering is perfect. So my next move is to actually plan on how I'm gonna connect everything. Remember, I said transformer. My transformer, okay. My transformer is gonna be on. This is transformer. Remember I said the transformer, let me put the multimeter aside for now. Okay, I said the transformer, I want my transformer to sit like that there. So I don't want it to be fully against here because I need some room so I can be able to drill here and let my wire go through. So that's it. And what else? Alright, so my transformer is going to be sitting right here. Alright, there we go. So I'm going to use this to hook it up. Applying this. Okay, I want to. So let me let me make sure it's going in. Okay, so it's the right size. 4 is the right size. Okay, I just want to create enough room for the head of my screws to sit nicely. The head of this nut should sit nicely here. So I'm trying to so that it can sit. It's a little bigger, but yeah, I think it's max. There we go. So we're gonna have to be cleaning every time because this is the only space I have to be doing everything. So just when you don't have enough space, just clean your space all the time. It's good so that you can continue to perform in a very good environment. So I'm gonna put my transformer. So remember my transformer is gonna be like this, and then what I can do is I can take a flat. Let me see the flat screwdriver, and then just drive this one. All right. So there we are. Our transformer is sitting nicely. So now, what's happening? So this right here should be connected to the fuse. So I said I was going to put my fuse here. So if my fuse is here, it means my the switch should be somewhere here. Let me test the switch for continuity because I want to know which side I'm gonna use. So when the switch is like this, I assume it's closed. So continue to test again. So because I want to see the position of the switch. So when it's on the left side, like this, okay, it means it's closed between these two. So if it's a, okay, I'm gonna, okay, on, okay, so let me follow this. So if it's like this, so it means this is closed here. So when the toggle is on the right, it means it's switched between the right, left and right. So when the toggle is on the left, it means it's switched between, okay, that's easy. So I should remember that. Alright, so I'm using this one. So when the toggle is on the left, it means it's switched on the right side, right and medium, the one in the middle. So let me put the drill for the fuse. So I want my fuse to be in here. I want the fuse to be a little upper because it's gonna go all the way here. This is how much space the fuse will take. Where's the fuse? Okay, this is how much space it's gonna take. So it's gonna go all the way here. So I want it to be a little on top. So I'm gonna use 16 right here. What I'm gonna do right now is let me hook the fuse. So this is where my fuse is gonna come. So it's gonna come here. And then the switch is supposed to come here. So I don't need a bigger hole for the switch. The switch is gonna be like this. So remember, so when the toggle is pointing on the left, it means we are switched here. So if it's like this, so it means we're gonna use this too. Alright, that's what I'm gonna do. So I want it to be off like this and on like this. Off, on. It's alright, okay. Good. So it's gonna be somewhere here. So the switch is coming here. So here is the fuse hole and the switch hole. So best thing to do is to so I'm gonna hook the switch on. The switch is on. Tighten there. So this is gonna be easy, because what I'm gonna do is, it's gonna make it easy for me. I will just solder there. I'll just solder there while it's there. Just solder it. And now I also have to be careful for the heat, the temperature. So my hook is on, the switch is on. Now I'm gonna introduce the fuse. The fuse comes on like that. And then so now our fuse also is solidly attached there. So now we're getting good. There is progress. So if we understand the steps, this wire is gonna come to the fuse here, right there. That's where we're gonna solder it. So we're gonna solder it here. So we can insulate this, or we can leave it like this, because there's not much. Let me see how much insulation do I have. I can use this one. Alright, so this one is gonna come like this. So this should be easy to solder. Alright, let me push the insulation. So the insulation, we just want to cover this, so that it does not there. And I'm using the lighter to just okay, it's quite good, just to so that it can stick. All right. Now we're gonna go from the fuse. So now we're gonna come from the fuse here. So let me use the long nose pliers to just bend it a little bit like this. So we're going from the fuse. I'm gonna use that insulation again. Look at the small piece again. So how many pieces do I need? I think 2 pieces. So something like that. 2 pieces of insulations. How this will do it. Alright. So where are we going from? From the fuse. From the fuse to the switch. From the fuse to the switch. Perfect. So I'm gonna put the insulation in because since I'm gonna solder. Okay, let me turn the switch a little bit first. I'll tighten it a little bit. Okay. No, it's not gonna be easy, but yeah, but not impossible. You can still conquer it. Okay, I have to insert my insulation because there should be another piece of insulation here. So and then bend it a little bit like that. And then I perform my soldering. There we go. Perfect. So it's tight. Now I'm gonna use the side cutter to cut a little bit. I'm on the camera to cut there. Okay. Now it's fine. So I can just send. Okay, I'm gonna put the insulation later because I don't want that heat to disturb the insulator. I still have to solder the other side of the switch. Okay, so I'm gonna put my supply cable here. So which means I need to drill there. Just somewhere there. Okay, so I was trying to find a way to fit the insulation cable so it can be firm. So I found a very better way. It's very firm. So I had just to increase the size of my hole so it can hold it nicely. So it's very tight. It can be put in so it's very. So our next thing is also I have also so the brown wire is the live wire that's gonna come here. So it's there gonna be a lot of wire here and there. So you can see already because number one, my fuse was very big, so I'm really doing my best to make it look as good as it can, but it's not gonna be easy. And so the brown wire from the supply is gonna come to the switch here. The blue wire is gonna come to the other uh, input wire of the transformer. The I can leave this one like this because this is a very small project. Actually, you earthing is not really a big deal. But the other safest thing I can do is on the plate of the transformer there, on this, on let me use that, on one of the screws, I can just connect my earthing wire there. That's the safe one of the safest thing I can do. Or I can just leave it here. This is a very small project that I don't think it's gonna have much impact on the leakage of current and so on. But to be safe, to build a very decent project, I will take my earth wire, then attach it to this metal of the transformer here, or this one here. But I will use this one because there is enough room here, and here it's very tight because all my wires from the supply cable are coming this side. So I'm gonna use that side there. All right. So let's proceed in soldering the. So I'm gonna put in the insulation. Let me take a new one. I'm gonna put in the insulation. So I just need a small piece of insulation. So I'm gonna take in the insulation before I even start soldering. Put it there. Alright, so this one looks much good. Okay, it's the right size. It's so now I'm going to, here you have to be very meticulous here. So you have to be very meticulous because remember I'm soldering on board. So you have to be very meticulous. That will do it. So bring the solder. It's working. Perfect. Everybody's happy. This is good. So I'm gonna cut the excess solder. So somewhere there. So I can now tighten my, just make sure no piece of solder or metal stays inside the box. So I can now tighten the switch with a long nose. So I can just tighten. So I think I've done everything I'm supposed to do with the switch. Let me tighten this. Alright. So here cut to the insert. So this is now the blue wire is the neutral wire that's gonna join the other terminal of the transformer. So this is exactly what I'm doing. So the blue wire is gonna join the other terminal of the transformer. Insulate, remove insulation on both sides, and I can just solder them, or I prefer to join and then use the insulation on top. So that's the best. So I can just twist the wires. You could also solder those wires. I can just twist them. You could solder them. You could do that also. You could just solder them. You could do that so just to solidify the connection, and then cut the excess. And then do this. So remember, I would use a heat blower here, but since I did not bring it, so I will use the lighter just to give a nice finish to this insulation. And yeah, so you can see as the heat is approaching, I'm not even attaching the flame to the insulation. I'm just allowing the heat to reach it, and you can see it shrinking, and then yes, there we go. So don't touch it directly like that. Be careful because it's still hot. So that is achieved. So, and I can just put those wires, I can just bend them and then put them somewhere here. So that I can do that. So which means I will have, okay, let me also put the insulation also here. So insulation here and insulation there. I don't want to leave any contact uninsulated because yeah, there might be an accidental touch from any other pin, so which can cause. Oh, this is high voltage actually, so you might by mistake touch it. So let me bring some heats. So I'm gonna have to actually uh, turn the box a little bit like this because I want to have a nice angle with my lighter. So you're gonna have to excuse me for that. Mm, so I want to have a nice angle so that my lighter can actually be able to provide. Okay, this is good. So everything is looking good. There's a little bit of burn there, but yeah, we did a great job. So everything is looking good. Remember my box, I want to squeeze everything in this small box. So, and then one negative thing is that my fuse. So I didn't, as I said, in my stock I don't have a small one. So this is the only one I have. So it's taking up a lot of space. But we have done something significant. So what our next? We said we were going to hook the earth wire. We're going to hook it there. Yeah, something's happening to my wire stripper. I don't know if this is it's the type of wire, but I can also use a different method with the side cutter because my wire stripper is not could not assist me here. So I managed to use the wire stripper. So let's untighten this side again. So I'm gonna put my and then untighten there. I think up to there is fine. Okay, this is not gonna be easy. Definitely believe me. This is not gonna be easy, but there's nothing impossible. As we said, not easy doesn't mean impossible. So we can still do it. Yes, and there we go. So we managed to do something there. And there we go. So now we're gonna tighten it. So all right, good job. So as you can see, we managed to put the earth wire to this plate of the transformer. just for some safety purposes. But yeah, we didn't really need, because this is a very small project. But yeah, for the sake of safety, we had to do that. Okay, now here is the secondary wires of the transformer that goes straight to the bridge rectifier of our electronic parts. So there. So this one is supposed to come here. So doesn't matter the order. So since I used this as my live, so this is still gonna be like, so my circuit was like this, so this is down here is gonna be like the live. Just put it like that, and then the neutral. Remember here, this contact here, this line here was the line for live, and this one here, I mean live here, neutral here. So I'm gonna plug this here and then plug this here. So that's what we're gonna do. So we're doing good. I would say we are doing good. So let's remove the cut off out of the way, lighter out of the way, and I'd say we're doing quite good. So I'm gonna hold it with this. Yes. Alright, so cut another piece of solder. That's clean. And then this one here. That's also clean. Okay. Good. Okay, we can still trim this. It's a little longer, we can still trim it. And then this one also, trim it a little bit. So now we have connected. So we have actually, this circuit is actually done already. We just have to connect our the LED holder and then the power point. But the circuit is technically done, already done. So, and let's also put the plug. Let's hook our plug in. So I'm gonna need screwdrivers for this. All right. So I want this to be like this, so I can take it up to there. Let me do this there, so I can cut it here. This will be fine. There is a stripper that can remove this, but you, as a technician, you should know how to manipulate all your tools. Because as a technician, you are there to create ways to obtain result. So that was easy. So this this is gonna come like this, so I want it to actually be like this. So this one is gonna open, so it's gonna sit actually like this, so that it can stay tight. So that's how it's supposed to be. So I'm gonna remove the insulation. Alright. Twist. You want to twist because you don't want the piece of the stranded to, end up at the wrong place, because it might touch a contacts that it was not supposed to touch. So you don't want it to end up at the wrong place. So, and let me use a flat here. So I'm gonna untighten this. Okay, it was already tight. It was already untightened. So we're gonna start. Let's start with the neutral. So neutral. Our neutral is here. So that's gonna be the blue one. So remember, our neutral was the blue one. So I don't want to remove all the I don't want to remove I don't want to take off all the screws and then start hooking them up. It's easy for me to just do it like this. Very tight. And then the live is here. It's actually indicated L. I don't know if you guys can see that, but this is the L and this is the neutral. So that's where the blue wire is gone. Now the brown wire is gonna come on the live, because that was the live. So blue wire on the live. There we go. And then again we tighten it. And make sure it's tight, very tight. And then our neutral will do the finishing. So neutral, earth, sorry, earth. That was the earth. The earth. So the earth is gonna do the finish, and then earth. So good. Our earth is well secured, and we tighten. This is the easiest part. This is the easiest part. A lot of you do this. So all of us do this. This is the parts where we enjoy, because we just want to hook up the plug. So this is the parts where all electrician enjoy. Some of us even get bored with this, then we give it to our kids or to a student. Can you just do that? So we like to do that most of the time. But make sure you have followed the polarity, and then I'm gonna close it, and the screw is right there, and we're gonna screw it back. So we have done quite a good job on the plug. There we go. So clean my space. I have to clean every time. Alright, so AC part is all hooked up, and then we've connected the transformer to the electronic board. Now what is our next move is to put the LED. So I want the LED to be this side. Oh, can I keep the LED this side while I'm putting the... Okay, since the LED is this side, these wires are too long, they can easily come this way. So I'm going to hook now the connectors, the power connectors. The power connectors. So I'm talking the negative which is the black one, and the positive, which is the red one. So this one is going to come here. So I want to keep my positive on my left side, so it's going to come here. Positive on the left, negative on the right. So let me take okay, this is the right side. So this one is going to come here, right in the middle. Okay, we're doing good. I think it's too small. That's right. It's not bad. Not bad. This is gonna be easy. If I already solder the wires, so this is the terminal wires, so you can start with this one. Just comes in there. Can I also use, I can also use the insulation there. It won't hurt to use insulation. So I'm gonna put in the insulation. So that's the red one. Put the insulation. I think I also have a black insulation. I'm gonna check that. So all right, we're doing good. This is perfect, very perfect. And then we go to the second one. I'm gonna take a piece of insulation again. Let me take the black one. Since this represents the negative, I'm gonna take a black piece of insulation. Oh, okay, sorry. So I didn't know I was already out of the video. So do that again. So let's hold it like this. Perfect. Perfect. Not a perfect job. So all we can do is just bring this and then put some fire. And then I just want to change the angle. With a heat blower, it would have been much easier. one. Okay, this is bad because I'm leaving the video actually, so I have to be checking on my monitor if I'm still on scene or I went off scene. So sorry about that, guys. So I'm back. Let me fix this one also. Okay, quite good. Not bad. Not bad. So good. All right. So this is. We also have to put the LED holder. We're gonna trim. Trimmer. So clear everything. Good. Okay. So if this comes on here like this. So after drilling, there's the LED hole. So I'm gonna take the LED holder, push it in like that. See how clean that looks. That's right. Everybody's happy. And then the LED from inside is gonna come there. That's how the LED is gonna hold. So that's gonna be quite a good job. Okay, so let's hook the terminals. Then this job is almost done. Almost. So positive, hook on the positive, push, yes. And then the positive is gonna come here. And then we close. We tighten this. We tighten the bolt. So we have tightened long nose pliers. Yeah, this is great. And then we connect the negative one. Here's our negative. And we put this. So once again, once again. Okay. this is good. This is good. So everything is actually ready. So we're gonna test the circuit, take some measurement, then we close it and we label it. So what I'm gonna do now, but this project look very decent. It's well done. So I've done my best to insulate all the wires that might have been exposed. So there's the transformer. This is my this is the plus and minus the output of the DC power supply. So I've just labeled there 12 volt DC. That's the plus, that's the minus. So we've managed to hook that up also. So there's my supply cable and plug, and there's the switch. So let's test this and see if some magic is gonna happen. So everything is looking good. The electronic parts. Remember, if you are building a 5 volt, you're gonna have to replace the pin. Everything is the same. All other components are gonna be the same. So as we mentioned during our planning, we were supposed to use a 5 volt. I've all of a sudden switched because I want to use this box for something else. So I needed 12 volts. So we have used a voltage regulator integrated circuit called L7812. So that means we are producing plus 12 volts. Remember, the 7 8 represent the positive voltage. If you want to produce 5 volt, all you have to do is to select a, a voltage regulator IC that says 7805. That's when you're going to produce a 5 plus 5 volts. And if you want to produce 18 volts, then you're going to select one that says 7818, and so on. So in my case, I needed this 12 volts. That's why I had to switch my project immediately. So I needed 12 volts for something else to supply to something very small. So this project, it should work. Everything is perfect. I explained how the wire came from the transformer output straight to the fuse, from the fuse to the switch, from the switch back to the supply cable, and the neutral wire of the supply cable is touching directly to the other primary wire of the transformer. The secondary wire of the transformer is connected to the bridge rectifier. So this is our bridge rectifier connection, as we discussed. So this is so up to here it's safe, and that's why I've insulated all this part, because this is the AC part. So let's plug this and see if this is gonna work. I'm gonna take a few measurements if you need to see some measurement taken, and then I'm gonna put this thing and close it. So I had to bring the extension here so you guys can be able to see uh, how. So we're gonna plug the supply cable to plug there. Okay, so there's the LEDs on, so it's working. It's working. So switch off, and when you switch off, it's gonna that's the capacitor discharging, because this is a large capacitor we've used. So when I switch on, it's on. Let me show. Okay, there. It's on, and when I switch off, the capacitor takes time to discharge. That's why you can see it's dimming off. That's it. So the circuit is working. To confirm that, we need to test the voltage on the output. We're supposed to obtain 12 volts, but it's not gonna be like 12 volts. Like it might be 11 point something, or strictly 12 volt point something, or 12 volt straight. So this is a regulator. So let's see. There's my positive. So I put my multimeter Okay, I should put the multimeter here. So I was off, I'm on. Let me see if I can open this. No, it's not gonna work. You're not gonna be able to see. Okay, now you can see. So I was off there on my multimeter. This is DC voltage. This is AC voltage. So I switch on to DC voltage and 12 volts there. So you might want to know other voltages, like for example, if you let me take a different pen. You want to know the for example, if you're asked to measure the transformer secondary voltage, you can measure the transformer secondary voltage. If you are asked to measure the transformer secondary voltage, you can measure the transformer secondary voltage. Let me put it like this. At this point here, at this point here, because this is where the transformer is coming. So, like in our case, I can just touch my, but this is an AC voltage. If you remember, this voltage here is AC voltage. So, which means I must switch my multimeter on AC. I'm there. This is DC. I switch to AC. Then I take my probe and measure the voltage on one side of the volt. This is here, and here, because that's where the transformer is coming. So in fact, this whole line, that's the AC line. So that's what I can do. Take my multimeter and then just come here. So I'm here and here. So my voltage says 18 volt. That's how much is coming from the secondary of the transformer. Remember, the transformer said 15 volt, but 18 is acceptable because the tolerance also is involved, and so 18 is acceptable. It's still within range. So that's your secondary voltage uh, uh, of the transformer. So secondary voltage on the transformer. So you might also be asked to measure the voltage regulator voltage, or the voltage across, or you can also call it, so do you see this voltage here? This voltage here is the same as the voltage on the input pin of the voltage regulator. So if you put here and you put there, that's still the same thing. Here, between here and here, that's still the same thing. So that's voltage. You can obtain it on the between these two. So you can take a multimeter, you're positive on this point and you're positive on this point, you are still measuring the voltage of the bridge rectifier. So you can bring it here or here. So that's where you are. That voltage is supposed to be the same. So I can take it between here. So now it's DC. So here it was AC. We got 18 volts. And now we'll go back to DC. That's the only AC voltage. That was the only AC voltage from the transformer. After that, all voltages are DC. So switch back to DC and then you measure here and here. So I'm obtaining 22.54. Let me put my multimeter like this. So if I put the voltage between positive and negative there, I'm obtaining 22.55. So that's the voltage. It's gonna be the same voltage on the input pin. So as I said, here and here. Let's check if it's the same voltage. That's the input pin, the in on the voltage regulator. So still DC. So pay attention as you are. Do your best not to allow your pin, the pin of your multimeter to touch any other thing. So I'm gonna put it there on the input pin of the voltage regulator and the negative. So my negative is here. I can also take it here, or I can just use this. That's still a negative also. This side here, still a negative. So the voltage is still the same, did not change, 22.50. So what I'm trying to tell you here is that if you are asked to measure the voltage, if you're asked to measure the voltage of the secondary of the transformer, you can take it from, you don't have to disconnect the transformer and go straight to this wire, because remember the transformer is soldered here. You can turn at the back, and measure it here at this point here, but you don't really have to turn the whole circuit to take that voltage. You can just come on top here on this diode here, that's your AC. You set your multimeter on AC, because remember the secondary voltage of the transformer is AC, and then you take it there at AC. Now, once you are asked to measure the voltage, the voltage of the bridge rectifier, which means the output voltage of the bridge rectifier is the same voltage across the capacitor, is also the same voltage on the input pin. So it's also the same voltage between this and this. That's the input voltage on the bridge rectifier. So this voltage here, so let me show you where I am. So you are talking about this one. This voltage here between positive and negative of the bridge rectifier, between positive and negative of the capacitor, between input pin of the voltage regulator and the negative pin, there's the negative line, it's the same voltage. That's the one we obtained, 22.56. Now, when they ask you to measure the output voltage, you can come straight here, the output, the final voltage. You can come straight on the output here, you measure it. There, that's your 12 volt right there. That's the one. Oh, we are on DC. So you come here, you measure that 12 volts there. That's it. That's the output. That's the V out, the output voltage. Or you can also measure it. You can measure it here at this point. On the diagram, you can measure it here. That's what we are doing. We are measuring, my red is there. We are measuring it here. Or you can directly measure it from the output pin with the negative. It's still going to be the same voltage. It's here or it's here. It's still the same voltage. It's also going to be the same voltage across this capacitor. It's also going to be the same voltage across the resistor pin that is touching the positive and the cathode of the LED. So that's it. So these are the different voltages that you can measure, and remember to switch between DC and AC. The only time you are measuring AC is on the secondary of the transformer or on the primary of the transformer. So anyway, the only time you are measuring AC is on the transformer. When it's not on the transformer, then it's not AC. Everything else is DC. So let's close the circuit and test it again, because we must close and test it. So we switch off, and the LED is taking some time to discharge, and it's completely discharged. Yes. Now we unplug, remove the plug. So just safely remove the plug it. Now we're gonna find a way to make the circuit sit down. We can use a masking tape, but it's not really unnecessary here. Because if I want to remove the circuit for testing, so I'm gonna find a way to have the circuit sit nicely. Because you want the circuit to sit nicely sitting there, like that. Oh good, this is beautiful. So the circuit is sitting nicely. It's sitting. It's sitting. And then we push our LED. So I'm gonna keep this a little lower here because I want to keep the wire. This is what I've done. And nicely I'm gonna push the LED out here. There. And that's how my LED looks. Very easy. So it's really an LED holder. It's holding. So that was the reason why we insulated the pin of the LED, because sometimes when you push it like this, they shouldn't touch. So this is perfect. And then we take the lid and we close. So, and this is that. So something like this is what they expect you, and this is how it looks at the back. So pay attention also when you are doing your alignment. You can choose to put your switch. I decided to put, because of my fuse that was very big, so I'll put it right in the middle, and my switch is here. And the front, this is how it looks. So I only have my pin and my indicator. So this is it. It's quite a nice job. It looks good. It's practical. So let's plug, and we still have to measure again the voltage. So there we try again to plug it. So plug. It's on. It's plugged, but we didn't switch on yet. So we're gonna try to switch on. I would love to do this so there's my switch, and I'm gonna switch. So I want to be able to see the light. The LED is on. So with our LED on, now we can take the measurement to confirm that when we close this, it was still working. So, and we take the measurement. So I'm gonna put the plus to plus, red to plus, my red pin of the multimeter there, and my black there, and we are measuring 12.1 still. So we're good. This was quite good. It was a nice journey. I hope you enjoyed the project. Nice work.